I'm going to go ahead and share my screen, but let me shut my camera off. It normally streams a little bit better when I do shut my camera off. And then we're going to go ahead and share my screen. And we'll have a chance to take a look at our motor story PowerPoint. And Randy and Robin and team, if you would please, my champion team, if you guys will kind of be the monitors to make sure that the screen looks good and all that kind of stuff. And if there's, of course, any questions in the chat box, if you would please monitor that chat box and we can ask those good questions. Now, team, I am going to ask everyone to go ahead and mute your mic at this point so we don't get any echoes back there. But if you do have a question, either raise your hand and one of our champion team members that's monitoring the chat box will go ahead and voice that, or you can unmute your mic, ask your question, then mute it back up as we move forward through the program this afternoon. Can everyone see the screen okay?
Yes, sir. And I was going to add to that, at any time, if you have questions or anything, you can pop them in the chat.
Absolutely, absolutely. Okay, well, here we go. Well, team, today we're going to be talking about and presenting an overview of different motor technologies. We're going to compare some of their features, and we're going to explain some of the factors that Johnson Controls actually considers when applying each motor technology. Now, it should be noted we're going to be focusing on indoor blower motors today that you'll find in an air handler or a furnace product. So the function of any electric motor, the basic idea, the function of any electric motor is to convert electrical energy to a mechanical force, typically a rotating mechanical force. And the reason I say that is because there actually are what we call linear motors or linear rail type of devices that are a type of motor, but they move things along in a straight line. So when we're talking about motors for, the HVAC industry, we're going to be talking about a motor that's going to be converting electrical energy to a rotating mechanical force. Now, this mechanical force may be used to drive other devices like fans and blowers and blower wheels and pulleys and so on. And the motors we will be discussing today will be primarily residential indoor blower motors found on air handling units again, and furnaces. Now, the types of motors that we're going to be talking about today specifically will be a permanent split capacitor motor, which is pretty standard in the industry, electronically commutated motors. Now, if you didn't know this before, that ECM that we talk about, that ECM motor, it's a high efficiency motor or a high efficiency type of motor, and it's an electronically commutated motor. Now, that's just a fancy name of saying that a motor that does not have brushes in it and it's electronically commutated and it's a high efficiency motor. A little side note too, real quick, all your ECM type of motors are actually a three-phase motor, which we'll talk a little bit more in a little bit as far as how all that works, but they are technically a three-phase motor with three windings in there. And from a troubleshooting standpoint, you can take an ohm meter and take the module off of these ECM motors, and you can actually ohm the windings out. Now put this in your back pocket or kind of write it down someplace. If you ohm out the windings between an ECM motor, you take the module off the back and be careful, let it discharge itself, let it set for 5 or 10 minutes because there's some capacitors in there that can hold a charge. But if you take that module off the back, and you take an ohm meter and you start ohming between the windings or the wires that are going to the windings on an ECM motor, put this in your back pocket now, all the readings should be the same ohm value. And so that tells you it's a three-phase motor and the windings are all the same value as far as an ohm reading. So that's kind of a neat little troubleshooting tip. In addition, we're also going to talk about variable speeds motors, which are another type of ECM motor, but we consider those a premium ECM motor. So we have a standard ECM motor, which would be like the old X13 designation type of motor, and then a variable speed motor, which is a type of ECM motor, but it's considered a premium ECM motor, and we'll get more into that in a little bit as well. Any questions or comments so far? Okay. So let's take a look at some of these motor types. Again, we mentioned a little bit about a PSC motor. You'll see there's a picture of a PSC motor. Now that PSC means permanent split capacitor. And so please remember this, there's always going to be a capacitor that's going to be associated, specifically a run capacitor associated with that PSC blower motor. We also have on the right-hand side, we have a standard ECM motor, also designated an older type of designation as an X13 motor. And then the variable speed, the premium variable speed motor down below. Now you're going to notice that the variable speed motor has a module that goes on back of it, but so does the ECM motor as well, the standard ECM motor. So we'll talk a little bit more about that as we start looking at these different motor types and we start talking about some of the features. So let's start out with the PSC motor. So the PSC motor is a permanent split capacitor motor, and it will always have a run capacitor associated with the motor. So in other words, as you take a look at this motor, let's say a contractor comes in or a contractor's looking at this motor, he's going to be interested in various things about this motor. He's going to want to know what size capacitor goes with the motor. He's going to want to know the rotation and the horsepower and all that kind of stuff. We'll talk a little bit more about that later. But we always want to refer everyone, we want to always refer to the motor data plate for the proper size run capacitor. Now, this is very, very important. The capacitor will be rated in microfarads. Now, microfarads, also called MFD, what it is, it's a rating of the capacitor as far as how big it is, so to speak, not physically, but what it's rated electrically in microfarads. Now, microfarads are a rating for capacitors only. So when you're thinking about capacitors, you'll have a different microfarad rating. It's how they're rated. Now, remember, the same size microfarad capacitor must be used if replacement is necessary. So if I have a 5 microfarad run capacitor on this motor, I have to replace it with a 5 microfarad. Now, I'm stressing this because we're also going to note here in a minute or two, the capacitors have an additional rating called a voltage rating, So at any given microfarad capacity rating, it may have a voltage rating of, say, 370 volt or 440 volt or 560 volt. There's different voltage ratings that go along with that microfarad capacitor rating. So please don't confuse those. The microfarad rating is how big the capacitor is as far as its ability to act like a capacitor. But the voltage rating is how much voltage that capacitor can handle without breaking down or having damage to the capacitor. So the higher the voltage rating, the more heavy duty the capacitor is. So to give an example, you might have a 10 microfarad run capacitor that has a voltage rating of 370 volt. But hang on a second, you could still have a 10 microfarad capacitor that had maybe a 440 volt rating. And so that 440 volt rating just tells you that the plates and the insulation inside of that capacitor has a higher voltage rating. It's a little heavy duty capacitor. You could literally have, as an example, now it would be pretty rare in our industry, but you could have a 10 microfarad capacitor with 1,000 volt voltage rating. So the idea is the voltage rating has to do with the ability of that capacitor to handle or to tolerate a particular voltage up to its rating. So let's talk a little bit more about that. So if you have a capacitor, if you're going to replace a capacitor on a motor, let's say a contractor comes in or he goes out to his truck and he needs a 10 microfarad capacitor on this PSC blower motor. And he goes out to his truck and he notices that he's got the old capacitor happens to be a 370 volt, but he doesn't have a 370 volt rating 10 microfarad capacitor on his truck, but he does have a 440 volt voltage rated 10 microfarad capacitor. Well, it should be noted if the original capacitor has a voltage rating of 370 volt, you can use a 440 volt rated capacitor to replace it. Let me say that one more time. As long as the microfarad rating is the same and the capacitor is the same size as far as microfarads, if the original capacitor was like a 370 volt capacitor, you can replace it. It's okay to replace it with a 10 microfarad 440 volt capacitor because you're actually going up in voltage rating on the new capacitor. It just means it's a little heavy duty capacitor. Now let's look at the other example, but please note the other example is if the original capacitor that was on the motor, if the original capacitor has a voltage rating of 440 volt, then you have to use a 440 volt to replace it. You do not want to back off if the original capacitor is 440 volt, you don't want to back off down to a lower voltage rating. So in summary, one more time, if I have a 370 volt rated capacitor, I can always go up to 440 volt, no sweat. But if I have a 440 volt capacitor, I have to replace it with a 440 volt capacitor. I don't want to go down on the voltage rating when on a replacement capacitor. Any questions or comments on that real important capacitor replacement on a PSC type of blower motor? Any questions or comments? Okay, good. Robin, can you guys still hear me okay? We haven't dropped out on the audio or anything, have we?
No, you're doing great.
Okay, good. All right, well, fantastic. So let's dig in a little bit more on that PSC motor data plate example. So here's a picture of just a PSC type of blower motor. And when we take a look at this, if a contractor comes in and slaps this motor on the counter, in front of your counter guy, and he says, listen, give me one of these. And so some of the key things we're always going to want to absolutely make sure of is that on the replacement motor, we're going to want to note the horsepower. In this example, as we take a look at this data plate, we see that the HP or the horsepower on this motor that we're going to replace is a 1/4 horsepower. So we want to make sure we have the same horsepower. We want to make sure the RPM is the same. As we take a look at the data plate, we can see clearly that the RPM is 850. So we want to make sure that we stick with the same RPM. Voltage is very important. If you're going to replace a motor, so you got to make sure the voltage is the same. Let's take a look at the data plate, and we'll see over there below our source 1 part number, we see we have a V or for voltage, 208-230. And that HZ means it's 60 cycles. HZ means 60 cycles or 60 hertz. And that pH means it's a single phase. So the voltage rating is 208-230 volt, 60 cycles, single phase. And then if you take just a look under where it says pH or phase, it says FR. That means frame. And so frame is very important too. We want to make sure that the replacement motor is going to fit in the same place the old motor is. And in this example, that FR, that frame is a 48Y. So some of the physical specs on this motor are, it's a 1/4 horse, 850 RPM, 208-230 volt single phase, 48 frame. Any questions or comments so far? And then one very super duper important to kind of tie in with our previous slide and session. Very important. Please notice the capacitor, the CAP, the cap, or the capacitor size, and the voltage rating. As we take a look on the data plate of this motor, we see that it says it needs a 5 microfarad capacitor, 370 volt AC. But hang on a second. Let me ask a question. What if I go over to my shelf, or if I go to my truck, my service truck, and I have a 5 microfarad capacitor, and my capacitor is rated at 440 volt? Is it okay to put that on this motor? Yes or no? Anybody open up your voice channel there, your audio, and is it okay or not?
Yes.
Okay. Thank you. Absolutely. I appreciate that little quiz answer there. So yeah, so if I've got a microfarad, as long as I've got a 5 microfarad capacitor of 370 volt or higher voltage rating, I'm perfectly fine to put that onto this motor as a replacement capacitor on this motor. Good, excellent. Any
question?
Come on, questions or comments?
Yes. Does the shape of the capacitor matter?
That is a really good question. It absolutely does not matter. The only problem is, or the only thing you have to keep in mind, is the physical mounting. In other words, if that capacitor has just got like a metal strap that's holding it against like a like in an electrical panel, as long as the new capacitor will slide into that strap and you can strap it down, the physical shape makes absolutely no difference, only because it's, as long as it'll fit in the space that's provided, it doesn't matter if it's round or oval. Good question. Any other good questions or comments?
I just had one more.
Sure.
What if I've got two capacitors sitting on my shelf? One is a run single and one is a run dual.
Okay. Again, it makes no difference as long as if you take the dual capacitor, make sure that you're using the portion of it that says fan if you're going to put it on the fan, because on a dual capacitor you'll have a common terminal, and then you'll have a terminal that says fan, and then you'll have a HERM terminal. That's for the compressor. So if you have a dual capacitor, you'll have one side of it will be for the fan, the other side of it will be for the hermetic or HERM. That means that goes to the compressor. But if you had, in an emergency situation and all you had on your shelf was a 5 microfarad fan portion, and maybe the HERM was, say, 20 microfarad, I could use just the fan portion of that capacitor between common and fan, as long as it's got that 5 microfarad rating in our example here and 370 volt or higher voltage rating. Absolutely wonderful question. Good question. Any other good questions or comments? And it's interesting, that example, because I've actually done that as a serviceman. I've been in the field. I was in the field for almost 20 years before I started doing all this other stuff. And I've done those exact same things. I've been in situations where I went out to my truck and I didn't have just a 5 microfarad fan capacitor on my truck, and I was out in the country or whatever, and 30 miles to town, but I did have a dual run capacitor that had 5 microfarads on the fan side, but it said HERM on the other. Well, I didn't need to replace that part of it. I just needed the 5 microfarad side, and it was perfectly acceptable to do that. Good question. Any other good questions or comments? Okay, well, let's talk about some of the advantages and some of the considerations for a PSC type of blower motor. Some of the advantages that are pretty outstanding, really, are the fact that it's very simple. They're very simple motors and a very well understood technology. As a matter of fact, there's a long-standing application in the HVAC industry with the PSC type of blowers. As a matter of fact, I like to say if it's single phase and really more than a couple years old, it's probably a PSC type blower motor. The PSC type of blower motor has been around a long time. It has a very reliable and known service history. There's lots of these motors out there. That's why we're talking about it today. Even though we're migrating over to high efficiency motors, there's still lots of PSC blower motors out there. Very, very well known and reliable service history. And it's widely applied with lots of replacement motor options available throughout the industry. It doesn't matter what supply house you go to, they're probably going to have some PSC type of blower motors in stock. Again, they're a good solid motor. The downside or the consideration of a PSC blower motor, they're not near as efficient as an ECM motor technologies. They're, in the percentage world of efficiency, PSC blower motors are typically going to fall between about 55 to 80% efficiency, where your ECM motors are going to be much higher, into the 90+% efficiencies. So because they're not as efficient as an ECM motor technology, you're going to have limited SEER applications. And what I mean by that, you're going to notice that all of your high-end SEER equipment, it doesn't matter what manufacturer you talk to, whether it's us or other manufacturers, you're going to notice that you start getting more into ECM motor technologies as the SEER rating and the system SEER rating goes up. You start depending on ECM motors to give you those higher SEER ratings, because your PSC type of blowers are limited in their SEER applications and how far you can stretch your SEER rating, your system SEER rating with the PSC type of blower. They do have a potential limited airflow capacity because of fixed speed limitations. You can only run a PSC blower on one speed at a time. As a matter of fact, the motor must be energized on one speed at a time, or motor burnout will result. So you might have a 4 or 5 speed blower motor, but you can only run that motor, or you can only command on that motor one speed at a time. The motor is going to be controlled on a PSC type of blower. The motor is going to be controlled by some line voltage device. So the line voltage device could be a relay, it could be a contactor, it could be a line voltage switch, and so on. Not low voltage inputs like an ECM type of blower motor. So one of the really neat things about an ECM type of blower is it uses 24 volt, typically low voltage inputs to it. So your PSC blowers are going to have line voltage making and breaking, different winding connections. Also, the motor is dependent on a run capacitor permanently wired into the circuit to provide for power factor correction and start winding current limitation. And so the reason that run capacitor is in that circuit is to correct for power factor and to limit start winding current. And that's permanently in the circuit, which actually affects the efficiency, the overall efficiency in that motor, because that's one component that stays in that circuit, and it is pulling some amperage itself as it's permanently wired into that circuit. And then finally, some of the considerations that you should think about with a PSC blower is because it's fixed speed, it's not optimal for humidity control and comfort. And what I mean by that is this: because it's running at one speed and only one speed only, you don't have the capability of like ramping up and ramping down to maintain a better comfort level and humidity control like you do with variable speed blower motors, or even some of your standard ECM blower motors. They've got a certain profile where they can ramp up and ramp down some within that speed tap selection. So very, very limited on what you can do with that. You can select one speed at a time, and that's all you're going to get on a PSC blower. So even though it's a well understood and simple and reliable, they do have some limitations as we've talked about. So any questions or comments on the PSC blower, motor advantages and considerations, before we jump into some of our ECM motors, our high efficiency blower motors? Any questions or comments? Okay. Well, let's take a look at our standard ECM motor, also called an X13 motor. This motor is an electronically commutated motor. That just means it's a three-phase type of motor that's going to be driven by an electronic module and controlled by selecting particular speed taps. Now, typically these standard ECM motors, they're going to have like 5 speed taps on there. Now, the electronic module itself actually converts single-phase power to a variable frequency 3-phase power source. So what happens is that module on back is going to take single-phase power, 208, 230 volt typically, from the power source. It's going to convert it to a DC voltage, and then through the power electronics, it's going to be switching that DC voltage into a modified 3-phase variable frequency 3-phase power source. Now, it should be known the standard ECM type motor is commanded by low voltage speed taps. Now, this is very, very typical, and they're going to be 24 volts typically. So what you'll do on this motor, you'll actually put, you may have 3 or 4 speed taps on this motor, all 24 volt. And it should be noted that the ECM type of motor, whether it's a standard ECM motor or a variable speed ECM type of motor, it can take multiple speed commands. It can take these 24 volt speed commands. You might have a command for low, medium, and medium high at the same time. It doesn't care what it's going to do. It's designed, if you have multiple speed commands on it, it's just going to automatically take the highest command that it's getting. So unlike a PSC blower that'll burn up you'll burn the motor up if you have more than one speed command to a PSC blower. These ECM motors, they could care less. You could have 4 speed commands to go into it, all 24 volt commands, low, medium, high at the same time. It doesn't matter. This motor will take those speed commands and it will automatically always go to the highest speed command that it's receiving without any damage to the motor at all. So that's a huge advantage from a controls standpoint to be able to feed this motor, or to give this motor multiple commands, and it'll just automatically take it. And those commands, by the way, they're a 24-volt signal. So it could be a direct command from a thermostat or a relay or other devices to give those speed commands. Now, please let me caution everybody, all ECM type motors, including a variable speed motor, have line voltage applied to the motor anytime the power source is on, even if the motor is not running. Let me say that one more time. You got to remember, ECM motors are powered up all the time, and they're just waiting for a 24-volt command to tell them what to do. But if there's power on that air handler, even though the motor's not running, it has line voltage to that motor all the time. So please be careful if you're handling these motors, if you're working on these motors in the field. Remember, there's power to them, there's line voltage to them all the time, even if they're not running. Another little side note, please write this down or put this in your back pocket, that if you remove an ECM motor from a blower housing, or from an air handler or a furnace, and you shut the power off, please let that motor set at least 5 to 10 minutes, because there's a bunch of capacitors inside that module and back that will actually hold a voltage. A capacitor has the capability of holding a voltage, a charge, in other words. And so you want to make sure that if you remove an ECM motor, or you unplug it or shut the power off, don't take it apart. Don't touch those line voltage terminals and stuff for at least 5 or 10 minutes. Let that motor sit there and discharge those capacitors for safety. And one more time, please remember, anytime there's power to an air handler or a furnace that has an ECM type of motor in it, or a high efficiency motor, there's going to be power to that motor all the time. And it's just, even though it's not running, it's going to be power to that motor, and it's just waiting for the 24-volt speed commands to tell it what to do. Any questions or comments on the standard ECM motor, some of the features, before we jump into some of the considerations and some of the advantages of this type of motor? Any questions or comments? Everybody good? Okay. All right, now I would like to ask everyone to please note that the terminals are different than a PSC type of blower. A little text field, I want to remind everybody with that. You'll see that there's just, instead of like wires coming out and a capacitor and all that stuff, we just have these terminals on the back of the module itself. You'll notice there is not a capacitor associated with this motor, because it's a high efficiency standard ECM type of motor. And then finally, the motor may take multiple speed commands, and it will always drive to the highest speed command that it gets. And again, those are 24-volt commands. Okay, let's talk a little bit about some of the advantages and the considerations of an ECM type of blower motor. So some of the real advantages, it's a high torque motor, and it's excellent for higher static airflow applications. So if you have a situation where you maybe have marginal ductwork, or maybe the ductwork is a little bit longer than it was designed to be, or just for whatever reason, the ECM type of motor will actually deliver airflow where you may have a PSC type of blower motor struggling to deliver airflow. So an ECM motor, it's a high torque motor, it's a 3-phase type of motor. And again, it's excellent for that higher static airflow applications. They're more efficient compared to a PSC type blower, because as I said, it's a 3-phase type of motor that's actually driven by a module on back that converts single-phase power to 3-phase power. You're also going to have a soft start on these motors due to the electronic module and the drive system. So unlike a PSC blower, that when you just start the thing, you just have line voltage going to that winding, and it just kicks it right off pretty quickly. The ECM type of motors, they'll actually sit here and rock a little bit. When they start up, they'll kind of rock a little bit, and that little rocking action, that's normal. What that's doing is actually finding its rotor position, but it's also decreasing the starting amperage on that motor. And we like to call that a soft start. So it's really a soft start type of situation that makes it easier on the motor to start it up. And it also reduces that inrush current, or the amperage, to get that motor started, that soft start feature. In addition, multiple speed commands do not damage the motor. Unlike the PSC blower, if you were to put more than one speed command on a PSC blower, you're going to burn the windings up. On an ECM type of motor, multiple speed commands are absolutely normal, and it doesn't hurt the motor at all. Finally, field module programming kits are available to help reduce your SKU count. In distribution, you can actually purchase a field module programming kit, and we can certainly get you information on that if you're interested at a later date. But you can actually field program the modules on back of these types of motors, so you don't have to carry all different kinds of motor modules in stock. You can just have your basic 3 or 4 modules, and then you can program them. So that's a real nice advantage. Now, some of the considerations with an ECM type of blower that you have to consider: the control module may lose its program if you have a really hard power surge, if you have a high voltage excursion, like a lightning strike, or a utility, a real high voltage on the utility, it may lose its program. It won't necessarily burn it up, or burn the module up, but it may lose its program. Another thing to consider about the high voltage excursions: if it's high enough, it may damage the motor or the module. But then again, it can, any motor can be damaged if the voltage is too high. But unlike the PSC blower that is more resistant to a voltage excursion, your high voltage excursions on that motor module can cause damage. And then finally, some of the things to consider: surge protection may be recommended in certain areas of the country if you have an ECM type of blower motor. So if you're at the end of a utility line, or you're out in the country or whatnot, and you've got, wonky voltages out there, high and low voltage excursions. Low voltage excursions typically don't hurt these motors at all. It's if you start getting above about that 256 or 260 volt, it can cause damage to the module. So any questions or comments on the ECM motor advantages and some of the considerations that we've talked about before we start talking about the variable speed motor? Any questions or comments?
Joel, on ECM motors, it's not necessarily an ideal fit for oversized ductwork. So in old homes, I mean, how do you address that?
That's a really excellent question, Randy. So basically, ECM motors are not a fix for just lousy ductwork, like you said. That's true. However, with that qualifier in place, you always want to have proper size ductwork, and you always want to have, a proper airflow. Now, with all that said, of all the motor technologies that we have available to us, if you have an older home that has marginal ductwork behind sheetrock, or in an area that you cannot access and remediate, the one motor technology that will help overcome that static and basically push air where nothing else will push is an ECM type of motor. So even though it's not a cure-all, it will definitely improve your airflow if you have marginal ductwork in an older home and you just can't get to the ductwork to fix it. ECM type of motors, variable speed types of motors, they will ramp up and overcome, or certainly do a better job of overcoming that static pressure in that older duct system. So even though it's not a cure-all, to your good point, it's a definite improvement over a PSC blower when it comes to marginal duct systems. That is correct. Good comment. Any other good questions or comments? Okay, good. All right. Well, team, let's talk a little bit about the variable speed motor. Now, remember, the variable speed motor is an ECM type of motor. It's just a premium ECM motor. It's got some features and stuff that are pretty cool. In the fact that it doesn't have like individual speed taps on it like the standard ECM blower motor. But the variable speed ECM, again, is a 3-phase type of motor driven by an electronic module and controlled by a control board with jumper or dip switch settings for the airflow settings. So that makes it very, very convenient. You can set up your airflow on a control board with some jumpers or dip switches. But just like the other ECM type of motors, the electronic module converts that single phase power to a variable frequency 3-phase power source. the variable speed ECM type of motor is going to be commanded by low voltage inputs, just like a standard ECM. However, those low voltage inputs, those 24-volt inputs, will be coming from a control board and thermostat inputs. So again, it's going to be commanded by low voltage inputs, and it's going to have, it can take multiple speed commands at the same time. It won't hurt the motor. All the advantages of an ECM motor, except the variable speed motor, is really a premium ECM motor because it really has a lot more capability than our standard ECM motor as far as speed selections and so on. Now, I would like to caution everybody one more time, all ECM type motors have a line voltage applied to them all the time. And anytime there's power to that furnace or air handler, that motor is going to have power to it. Even though it's not running, it's going to have power to it. So please be careful when you're handling these motors or working around them. Now, you're going to note something. The control board itself actually has airflow jumpers or dip switches that you can select. So what's going to happen once you select an airflow based on your install information that comes with the equipment, once you install that equipment and you set the airflow up, what's going to happen, that motor is going to ramp up or ramp down to maintain that airflow. And to Randy's good question earlier, if I have a marginal duct system, of course, fix the duct system if at all possible. But if you can't get to the duct system and you can't fix it and you can't remediate the duct system, the variable speed motor is the best technology for moving air and to push air in those challenging duct systems of all the motor technologies we have. Now, make a little side note or write this down or please remember it. This motor will ramp up to deliver that airflow. However, the velocity is going to go up, and oftentimes the noise will go up as well. Because remember, if I'm trying to push a lot of air through a small duct, it can actually make some air noise. So just be aware of that. This is a very, very high torque motor, and it's very capable, and it will push air where nothing else will, but it'll do so at a higher static pressure and oftentimes higher velocity and a little bit more noise, a little more air noise, because it is delivering that airflow if you have a marginal duct system. Any questions or comments on that so far before we start jumping into some of the other cool things about the variable speed motor? Any questions?
Hey, Joel.
Yes, sir.
Hey, Joel, it's Dan. Quick question. Also with the ECM, the variable speed motor, doesn't that also provide dehumidification?
It does, and we're actually going to be talking about that here in a minute or two, Dan. That's actually one of the really nice features of the variable speed ECM type of motors that, with those jumper selections, we're going to have lots of options with not only heating and cooling airflow, but what we call the delay feature, which will give you some extra humidity control in those tough environments, where you're having problems controlling the humidity in the conditioned space. But we'll be talking about that in just a second or two. Good question.
Awesome.
Yes, sir. Any other good questions or comments? Okay. So as we said, the variable speed ECM motor does have a control board that we can actually set up some different airflow profiles and different airflow settings. And let's go ahead and talk a little bit about those. As a matter of fact, I've got a couple examples here. And so the variable speed motor, because it has a control board, jumper, or dip switch settings, the one setting that Dan was actually talking about a second ago is what we call the delay jumper, So as you take a look above the picture of the motor there, you'll see this graph, if you will. And what this happens to be delay jumper in the A position. Now, there's 4 positions on this delay jumper. Now, please bear in mind, this is a cooling on delay jumper. Now, what we mean by an on delay, what happens is whenever this fan motor gets a command from the control board for operation to come on, in other words, it's going to look at this delay jumper, and it's in the cooling mode now. So what's going to happen is if you take a look at this little graph, you'll see that for 30 seconds after it's commanded to come on, it's going to take 30 seconds to ramp up from 0 or 0 RPM up to 100% airflow. Once it ramps up for that 30 seconds, it ramps up to 100% airflow, and it will maintain 100% airflow on delay jumper A position. And this is just the normal position. This is the default position that it comes from the factory. And so it'll go from 0 RPM up to 100% airflow, and it will maintain that 100% airflow until the thermostat is satisfied. Once that thermostat is satisfied, that fan will continue to run for 60 more seconds. Even though the call for cool's gone away, it's going to take the cool energy. It's going to take the cool air. It could be pulled off of that evaporator coil, and it'll continue to run for 60 seconds. And then at the conclusion of 60 seconds, after the thermostat is satisfied, it'll then ramp down back to 0 RPM over a 30-second ramp down. So this is the normal position. Now there's 4 positions. There's A, B, C, and D on the delay jumper. The A is the normal default position. We have a dry position. If you're out in the desert, that's a different ramping profile. We have a temperate, like if you're in the hills of Tennessee, maybe you don't have a huge amount of humidity, but you got some mountainous and maybe some rainy days, maybe considered temperate. And then you have what we call the humid profile. The humid profile is the one I remember the most because I live down in the South, the Gulf Coast and whatnot. The humid profile is the B profile. And so we're going to talk about the B profile because it's such a distinct, different graph or ramp. So you see this normal ramp, 30-second up, 100% airflow, thermostat satisfied, runs about another minute, and then ramps down over 30 seconds to shut the motor off as you take a look at the ramp. Delay jumper B happens to be one of my favorites because it's the humid profile. I just happen to remember that from the install information. But as you take a look at this ramping profile, it's completely different. So what happens is on a call for cool, the motor, it takes 30 seconds. It'll ramp up to 50% airflow. And so you'll notice that 50% airflow. Now, please remember, everyone, in the cooling mode of operation, anytime you have lower airflow, it starts really wringing moisture out of the air. So the slower the air, the more humidity you remove over a period of time. So a colder evaporator coil, lower airflow. So it ramps up, takes 30 seconds to ramp up, and then it's going to hold 50% of its rated airflow. So if let's say I've got a 4-ton unit sitting outside, it's going to be actually blowing 2 tons of airflow for 2 minutes, 50% airflow for 2 minutes. Well, hang on, Joel. If I got a 4-ton unit sitting outside and I'm only blowing 2 tons of air, won't that evaporator get super cold? Yes, that's the idea. So for 2 minutes, it's going to be running at 50% airflow. And then after 2 minutes, if the call for cool's still there, it'll ramp up to 82% airflow for 5 more minutes. So we're running this reduced airflow on this unit, on this B, this humid profile. This B jumper is a humid profile. So it runs at half airflow for 2 minutes, and then 82% airflow for another 5 minutes. And then if the call for cool is still there, it ramps on up to 100% airflow and continues that 100% airflow until the thermostat is satisfied. Once the thermostat is satisfied on this particular airflow profile, it'll continue to run for about 60 seconds to get all the cool off the evaporator. No need to waste that energy. You've already paid to run the air conditioner, so we're going to run that for 60 seconds, then ramp it on down to 0 RPM. So this delay jumper B happens to be the humid profile that you have. So the moral of the story with the variable speed motor, the variable speed ECM type of blower, you have all these wonderful positions that you can, these airflow positions and these airflow selections that you can make in the field to really help control humidity. And it's quiet operation. It really wrings the moisture out. And by the way, if I can control the humidity in the house, along with some decent air filtration, I also have a not only wonderful humidity eating machine, but I also have a machine that can really provide some improved indoor air quality. Because remember, mold and things like that, they like it humid. And so if I can handle the humidity in the air, it not only makes you more comfortable, it makes you feel more cool at higher temperatures, but it also improves your indoor air quality. So that's a big thing too. So you got to control that humidity for indoor air quality, but also if you have customers that have like asthma or something like that, controlling that humidity really helps benefit people that have respiratory issues as well. So there's just a lot of good things to talk about with the variable speed and the ability to change that cooling ramp based on your physical geography. So Dan, that kind of answers your comment, Dan.
Yes, sir.
But any other good questions or comments along that line before we start jumping into some other things with the variable speed? Any other good questions or comments? Okay, well, team, let's talk a little bit of some of the advantages and considerations with our variable speed ECM blower. You notice there's not a huge amount of considerations, but let's talk about some of the real advantages of the variable speed motor technology. So point number one, it's a very high torque motor. When I say high torque, it's controlled by that control board. It's not just a simple speed tap like you have on the X13 standard ECM blower. So it's a very high torque motor. And it's the best technology that we have for higher static airflow applications. And again, to Randy's earlier point, it's not a cure-all, but please remember, if you've got a duct system that you can't get to, maybe an older home, and the duct system is behind sheetrock or in an area that you can't access for whatever reason, the variable speed blower motor will blow air where no other motor technology will. It's the best for that. It's the best technology for high static applications. And it's the most efficient compared to PSC type blowers and standard ECM motors. And the reason it's so efficient is because the control board, once you set your airflow up, that motor is going to ramp up and down to find the absolute ideal point to meet that airflow that you've commanded on those jumpers and those selections without blowing too much or too little. Because see, even on a standard ECM motor, you're going to have some speed taps on there, but those speed taps are going to be limited to the envelope or the profile of that speed tap. Whereas a variable speed motor is kind of like a jet engine. It truly is variable speed from 0 RPM to maximum RPM. And so this gives us the very best efficiency compared to those other motor technologies, because it's going to ramp up or ramp down to give the exact airflow that you've commanded, within 10 or 15, 20 RPM, whatever. So this is the most efficient, even amongst the ECM type of blower motors. It also is the best technology for humidity control, because we talked a little bit about that. You have those field selectable cooling ramps for optimal comfort, humidity control, and IAQ, and so on. So, you can't get any better than variable speed for humidity control. I mean, these things are humidity eating machines. To kind of give an example, the humidity control that you'll enjoy with like a PSC type of blower, you might pull out, couple 3 gallons a day of humidity, 3 or 4 gallons based on the tightness of your home. On an ECM type of motor, just a standard motor, that'll jump up to maybe 7 or 8 gallons a day. But on a variable speed ECM motor, you can just about double that because of that ramping profile. Excuse me. So the best technology for humidity control. We still have that soft start capability because of that electronic module. Multiple speed commands do not damage the motor. And then field module programming kits are available, again, to reduce your SKUs if you want to start programming these modules. Excuse me, team. Very easy airflow setup during installation. And it is the most versatile for outdoor matchups. So neat thing about the variable speed, it will literally match up with anything in our inventory, from 13 SEER northern region, to the HMH7, our horizontal heat pump, to our, 19 SEER 2-stage. It's an extremely versatile product. Some of the considerations, like any ECM motor, the control module may lose its program if you have really hard power surge. High voltage excursions above about 250 to 260 volts may damage the motor or the module. And then surge protection may be something to consider in certain areas of the country. So of all the motor technologies we have, my favorite as far as efficiency, comfort, humidity control, flexibility is actually the variable speed ECM type of motor. Any questions or comments before we talk a little bit about some of the rescue motors and some of the things that we have from our Source One team? Any questions or comments? Okay. Well, I didn't want to leave the training session today without talking a little bit about our fractional horsepower rescue motors. We do have a large selection of rescue type of motors available for your selection and convenience. Rescue motors are going to be the best applied when the OEM motor may not be available or in stock, or when repair may be time critical. So these motors really shine if you've got some of these on your truck and you're 30 miles away out in the country or whatever, and you just need to put a motor on, and it's so these rescue motors are very, very helpful under those type of situations. So just a little bit of a branding here, our Source One. If you take a look at our motors, what we call our time saver motors, they are a variable horsepower motor, and we have a wide selection of direct drive, furnace blowers, high ambient condenser motors, and so on. And they are color coded, so there's no question when you take a look inside, you know exactly what you're looking at. And I'm not going to sit here, this is a bit of an eye try, I'm not going to sit here and read the whole thing to you, but just know that we have a full line of rescue motors for condenser fan motors, blower motors, and furnace blower motors as well. In addition, some of the key points about our fractional horsepower motors are they're easy to cross-reference. They do have the extended bolts on them so that you can very flexibility for mounting. One of the things that I really like is the fact that we have extra long whips on them, or extra long wires, so you can actually get in there and put them universally where you need them. And also ball bearings. They have ball bearings which are going to be very, very high strength and long, reliable life with a ball bearing motor. I prefer a ball bearing motor over like a sleeve bearing type of bearing on the motor. So that's just a little bit of, again, a little bit of a high level view of our rescue motors that are available to you. And I didn't want to, again, conclude our training without giving you the opportunity to think a little bit about our Source One rescue motors as well. So with that really concludes our basic motor story today. I would like to thank everybody for training with us today, but please don't go away yet. I'm going to go ahead and close the PowerPoint down, and I'm going to stop sharing my screen. And let me go ahead and I'm going to stop the recording at this time as well, as we open up the floor for any final questions